Students, I'm Jalisha, Assistant Professor, Department of Mathematics, St. Joseph's College of Arts and Science for Women, Hosur. Today, in this video, we are going to see the principal disjunctive normal form, that is PDNF, using truth tables. How we are going to find the PDNF using truth tables in discrete mathematics. Let's see what is PDNF. In the previous video, we learned DNF. Now we are going to see what is PDNF. So for DNF, if three variables P, Q, and R is taken means its DNF form answer. The final answer can be of with P cap negation Q. DNF means common value should be cup. So in the bracket, I used here cup, and the next value is negation P cap negation R, and the next one can be of with Q cap P. So if these three are the answers for DNF means it is acceptable, because for DNF our aim is to get min terms in the bracket, and those min terms should be connected using a cup value. So that we got in this line, so we can say this is a DNF. Now the difference in PDNF. So in this question, how many variables I have given is three variables. So for PDNF, if as in the previous line we are getting only two variables in each bracket, that is min terms are with only two variables, means it is not accepted in the principal disjunctive normal form. So here we need to get actually how many min terms, maximum min terms will there for a PDNF? 8 min terms. So for both DNF and PDNF, it is not a must case to get all the 8 min terms as a final answer. But in PDNF, if three variables are used means in each min term value, all the three variables should be there. So only two bracket terms we are getting as answer for a given proportion means I have given here two brackets. So in all the two brackets, the three variables should be mentioned, whereas it can be in the normal form without negation or with negation. That is not a matter here. But if you are going to say a certain min term connected with the cup as PDNF means all the three variables should present in the bracket value if we are considering three variables. And if suppose you are considering two variables in the question means, then each bracket should contains two variables. So such type of output in the form, that is sum of product, is called as a principal disjunctive normal form. Principal disjunctive normal form, in short we'll call it as PDNF. So by two methods we'll be able to find the PDNF values. So the method one is by using truth table. In the next video we can go through with the PDNF value through equivalence formulas. So in this video we are going to see how to find the value of PDNF using truth table. In that method, the following steps need to be followed. First step is we will first construct a truth table for the given formula, that is already explained in the first video. In the second step, we need to identify only the truth values in that final output. So straight to that true value, you need to consider the min terms. So connect those min terms against of true with cup. That answer is called as a record PDNF. So let's move into the problem. Here the example is given as x tends to y is the expression, and we have to determine the PDNF with the help of truth table. So first we are constructing the truth table for xy. Instead of PQ, here they have given xy. So how many proportion variables are here? 2. So 2 means how many rows we need to have? 2 power n. Here n is 2, so 4. All those things I have repeatedly saying in all the videos. So based on that 4, the output first means 2 true, then 2 false. Next alternate true false, true false. So these are the outcomes. So based on this, we are finding the conditional. What is the definition for conditional? For x, you need to check true values, and in that true against of y is false means answer is false. So only this row, second row, is false when x is true. So for that we are giving true. So only two trues are in x. For that two we have cross checked. Only the second row is giving false value. First row y is true, hence true. Other two rows we need no need to cross check. Directly we can give the true values, because that condition is not necessary in the value definition. Okay, now using this, as per the method 1 for PDNF, we need to consider the true values in the output. So this is the output. So in that two true values are there. So three true values are there. So we have mentioned those two, three true values. Against to that, what are the min terms? It is possible here x is true, y is true. So min terms we can give as x cap q. And in the third row, true is the output. So against that, what is x value? False. So we need to represent x as negation x, and y is true. So q. We are giving the min terms, so connected by cap. In the last row true, against it x is false, y is false. So the min term will be in the form negation x cap, negation q. So only these three min terms will exist in the PDNF. So first term, second, third, as we are giving the PDNF, we need to connect those min terms using cup values. So now we got the PDNF. Why we are saying this as a PDNF means how many variables we are having? 2. So those two variables either in the general form or in a negation form, both the variables are present in each of the bracket. So we can say this as a principal disjunctive normal form. Let's move into the next problem. In this example, we have an expression x cap y cup, negation x cap z, cup y cap z, and we need to obtain the PDNF. But how many variables are here in this given question? Three variables x, y, z. So for three variables, we need to give. So totally we'll have 8 outputs, 8 rows. So for x, 40, 4 false. Next, 2 true, 2 false. Continuing. In z, alternate true, false is given. So all the 8 outputs we got. Based on that, we are framing the min terms first. We can have this min term in the last also. So here, what about the min term of this first line? All are true. So x cap, y cap is it. Next, only the last one is negation. So x cap, y cap, negation is it. Likewise, all the remaining min terms are noted here. Now in the question, what about the first bracket? We need to solve this questions truth table. Truth values we need to identify. So for that, first we are getting the value of x cap is it. Next, negation x cap is it, and last y cap is it. And finally, you want to apply cup between all these three brackets. So that will be the final. Cap means we know the definition. If two terms are true means answer will be true, otherwise false. What is cup? Any one is true means true, otherwise false. So here X cap is that means first and the third column you need to compare. Both are true means true, otherwise false. Here negation X cap is it means better. While you are preparing you just put a negation column here, compare negation X with Z and apply the cap definition. Likewise we need to find Y cap Z, and in the final column for these three columns we are going to apply the cup. What is the cup? Any one is true means true. See these three columns, the first row two terms are true, so we can provide the answer as true. Second, one is true, so true. And in the third, all are false. So not even one true, so false. Next is also false. The next one, two trues are there. Again, all are false. Then next is one true. Again, all are false. So based on that, we have given here the true values. Now for constructing PDNF, what is the condition? Only the true rows should be considered. So we are marking the true rows, and from that against to it we are checking its min terms. So see here, first one, then the next, then this one and this. So these are the min terms which are going to support to frame the PDNF. So connect all these min terms using cup. So the final thing, as we are having three variables in each bracket, we are having three variables either in XYZ form or in its negation form. So this is called as the PDNF of the given question. So here are some of the practice question. Go through with it. Thank you for watching it. The next video is on the PDNF problems solving through equivalence formulas. Thank you all.